Hi, my name is Pablo and I'm an application engineer in Infineon microcontrollers. Today I'd like to show you one of our touch controls application kit, the so-called 7 buttons application kit. This application kit is comprised of two different components. First of all, a mini CD, and second, the 7 buttons board. In the mini CD, which contents you can also download from the website, you will find different technical documentation like application notes, source code, or layout and schematics. Additionally, you can find the tool change needed to run all your touch control applications. So let's take a closer look to the 7 buttons board. As you can see, we have a USB connector to communicate with the laptop and also provides power supply to the board. We have as well a chip, which is a USB to UART translator, a switch which changes between bootstrap load mode and run mode, of course the 8-bit microcontroller XC822, and finally the 7 buttons, which are sensors for our touch. Over each of them you can find a LED which is lighting when you touch the board. The XC822 microcontroller allows up to 7 touch channels using a relaxation oscillator topology. One of the main important and most nice features of these microcontrollers is that you don't need any external components to develop your touch control. Mainly, you can connect your touch channels, your sensors, directly to your pins. Another important characteristic of Infineon microcontrollers touch is that LEDs and touch channels can be connected to the same pins, given that the microcontroller has the ability to multiplex these functions inside it. So now let's connect the USB cable to the board. After connecting, the microcontroller runs the software from the flash, and it runs some auto calibrations and some adaptive filters at the beginning. So after a few seconds, the board is ready to touch. Within touch control application, it's very important to be able to configure different channels independently. Let's take a closer look to our kit and see how it's possible to configure them independently. First of all, we need to import the code into DaveBench, which is a free compiler and debugger supplied by Infineon. Let's click on File, Import, System Project, and now we have to browse in our computer. Go to 7 buttons, DaveBench, touch button A, then OK. Finish, and now we can see our code in DaveBench. Now we can access the source code and modify wherever we want. But there is even a better option. Just go to Dave interface. The module responsible for touch and LED within Dave is the LED/TS, which stands for LED and Touch Sense. Let's go inside. Here you can see different tabs, and in the tab ROM library is where you find the parameters for adapting your touch application. Let's, for example, change the sensitivity of our touch. One option to change the sensitivity is to modify the offset parameters. As you can see, we can modify the offset for every channel independently. As an example, let's change the 4th channel and let's do it more sensitive. That means the offset is smaller. And for the 5th, we will do it less sensitive. So we'll do the offset bigger. Let's say 25 as an example. And the 6th path will stay as it is. Then we have to save and generate a new initialization code. As you see, Dave has updated the code. Now we can recompile. After a few seconds, DaveBench has generated a file called touchbutton_a.hex that we can download with float. Now you just have to click on download, taking care that your switch is set to the left. It's important that you select your COM port from your device manager correctly. After download and verification has finished, we can unplug the board, shift the switch to the right, and plug the board again. So now the microcontroller auto-calibrates. Now we have three different sensitivities. In the 6th pad, we have a normal pad as before. In the 5th pad, we have less sensitivity, so we have to push harder. And in the 4th pad, we have a higher sensitivity, meaning that we can see something like a proximity effect. So before I touch the plexi cover, it lights up.
Just to finish, let's go back to DaveBench to make use of U-SPY. U-SPY is a visualization tool integrated within DaveBench that allows the user in real time to monitor variables or parameters that are relevant for the application. After having configured U-SPY, we just have to click on the red button and then we receive data. You can click on the different pad buttons, for example pad 1, to monitor pad 1. So you can see we can monitor all the different pads.
As I've showed you here, it is possible to customize many other parameters to fulfill your application requirements within a few mouse clicks. So please check it out.